So let's do an example. When you combine a solar array with a battery, you're risk mitigated. So you can use all these different rate structures to save money, regardless of how your electric rate structure might change in the future. So for example, here is a $30,000 solar project in the Southeast United States. So, let's say it's a larger home with an electric vehicle on site. So this home in this example, we're energy hogs in the United States, particularly down south. We're using 2,500 kilowatt hours of electricity per month at 12 cents a kilowatt hour. And alternately, we can look at a variable rate structure, which instead of having a flat rate, you have a much lower off-peak rate and maybe a demand charge that's based on kilowatts instead of kilowatt hours, and then maybe a peak rate as well. So if you're not familiar with variable rate structures, they might be described as doing your laundry at night. It definitely will increase your cost of electricity during peak times, but it will reduce it during all other times. So normally, if you have a flat fixed rate for your electricity, there's not much you can do to get value out of your battery other than using it during a power outage, which in fact is quite valuable. But businesses have demand charges. Most businesses have demand charges, and that can make the battery more cost effective. So in this residential example, we have a demand charge. This could also be applicable to commercial projects. And here they give you an off-peak electric rate of a penny a kilowatt hour and a peak electric rate of 12 cents a kilowatt hour. So if you work the numbers, you take if you're working non-traditional hours, or if you can avoid those peak rates with your energy use, this can be a real savings. Just as a disclaimer on this budget, this is a sample budget. We're not actually talking about the actual MSRP of these individual line items to the installer or to the customer. This is just a budget that we think at least an installer can kind of consider when planning a project. So now let's get back to the show, talk about the payback. So in this example, we're using, let me get my marker out. In this example, we're using an 8 kilowatt battery inverter. And so we're assuming that the home's maximum power draw was 15 kilowatts. And now it's been reduced to 7 kilowatts. So they didn't have this demand charge on their old bill. So that was 0, but they had a much higher energy rate. So we're assuming that the solar array installed provides enough energy to charge the battery. And so these are pretty conservative assumptions for the solar array size and budget. You can run a PV watts model for more detail, but we're assuming the battery and the solar array can fully offset the customer's peak energy use, thereby avoiding the peak rate. And then the energy that they have left over is off-peak energy. And so you can see that even with 7 times 10, even with a $70 a month demand charge on the bill, that access to 1 penny a kilowatt hour electricity offsets the rest, resulting in quite a bit of savings. And so when you take the $30,000 budget and you apply the 22% federal tax credit, and you're looking at about $200 a month of monthly savings, you get a 10-year payback. And, a 10-year payback may not initially dazzle you, but think about it. First of all, all of the products in this system have a 10-year warranty and a true 10-year life or greater. You also gain, unlike with a batteryless solar array, now that you have a battery-based system, you gain the energy security that the client actually wants, of the grid being able to go down because of a hurricane and your family still has power even though the neighbors won't. So they're throwing out all their food, but you aren't. That's a massive savings in itself. Medicines need to be at the proper temperature. Your kids can still go to their virtual school and you can still work remotely, all because you have this backup system. Plus, by going on to these variable rate structures, you can add an electric vehicle and use even more electricity than you currently do, but not have your electric bill skyrocket. But it's just important to know that even without an electric vehicle, batteries aren't just for cars. You can take advantage of the rate structures available to you to increase the economics of the system. And what I think is especially important is that if you are in areas where you don't have access to net metering, where the solar buyback rates are non-existent or a bad deal from the utility, all of a sudden you have a variable rate structure with a battery and you get to a 10-year payback, even in a market previously where solar just didn't have any sort of payback because it didn't have the right net metering structure from the utility. And so particularly in markets where the utility does not buy back your electricity at a good rate, just add a battery.